All right, 8th grade math students, we are doing lesson 9.2 today, properties of reflections. These are your quote-unquote notes for this lesson. They start on page 285 and then we'll be going through page 287. You might be able to do these on your own without the video, but if you've gotten stuck, hopefully you're watching. As you go through, if you have questions, please make sure you're writing those down so we can go over them together. The way that I do this today, because I'm working on Promethean, is going to look a little bit different than the way you might do this on paper, but the process is the same. All right, so let's go ahead and take a look at our essential question. How do you describe the properties of reflections and their effects on congruence and orientation? And remember, congruence means what? Congruence is same size, same shape. Okay? And orientation is direction, right? So like top, bottom, left, right. So what we have here in Explore Activity 1 is we are exploring reflections. A reflection is a transformation, right? That means the type of transformation that flips a figure across a line. The line is called the line of reflection. Each point and its image are the same distance from the line of reflection. So each point, original point, and its image, so its change point, are the same distance from the line of reflection. That's important to remember. The triangle on the grid is the pre-image. That's the original. You will explore reflections across the X and Y axis. So first thing it wants you to do is trace triangle ABC and the X and Y axis onto a piece of paper. So if you don't have a piece of paper to do that with, what I want you to do is follow along with me, and we're going to do this together. So I've got my triangle here that I've traced, and we're going to imagine that I've traced it as a piece of paper, little piece of paper. So what it wants me to do now is fold the paper across the X-axis. So the X-axis is right here. Oops, let's go ahead and, right, so this is my X-axis. Oop, I don't want to move that. So I'm going to fold my paper across that. And then when I do that, I'm going to be reflecting triangle ABC across that line of reflection. Then you unfold and label your new triangle, your image, A prime, B prime, C prime. So what I'm going to do here is I've got some fun little tools that I can use to show what that looks like. So I'm going to transform, and I'm going to mirror, I'm going to flip on the X-axis. Whoops, that's not what I want to do. That flipped the whole image. Let's try that again. Okay, I'm going to transform. All right. Transform, flip on X-axis. Okay, so now I've got my new triangle here. It's been flipped on my X-axis, right? So from here across my X-axis, so let's take a look at that again. So here it is, and there it's flipped. Pre-image, image, flipped across. So it moved just a little bit, so I'm just going to make sure I relocate this here. Okay, because it should be, according to this, the same distance from the line of reflection. So if the X-axis is my line of reflection, I've got point C here, which is 1, 2 points from my line of reflection. So point C prime should be 1, 2 points from my line of reflection. So I'm going to go ahead and label those now. So if this is C, 2 from my line of reflection, 2 units from my line of reflection, this would be C prime. A, this would be A prime, and B, this would be B prime. Remember, you're using that correct notation. So the line of reflection in this transformation would be our X-axis, because that is what we reflected across. So our X-axis is our line of reflection. Your lines of reflection will not always be the X and Y axis, but it's nice when we're first learning about reflections to use those because it gives us a nice visual line. All right, find the perpendicular distance from each point to the line of reflection. So that means the distance from our line of reflection to each point. So if x-axis is my line of reflection, point A is 1, 2, 3, 4, 5 units from my line of reflection. So I want to write units. Point B, if x is my line of reflection, is 1, 2 units. And point C is also 1, 2 units. Okay, now I'm going to find the perpendicular distance from each point to the line of reflection for my prime, right, for my transformation. So if I look at A prime, it should be 1, 2, 3, 4, 5, right, 5 units from my line of reflection. Point B prime is 1, 2 units from my line of reflection. And point C prime is 1, 2 units from my line of reflection. So when I look at those, when I compare those, which is what I'm doing in F, what do you notice about the distances you found in D and E? Well, what we notice is that the perpendicular distance, meaning the distance from our line of reflection to our point, is the same for our pre-image as our image. So we could say something like they are the same for a point and its reflection, or the perpendicular distance is the same for each point and its image. Right, that means our after. So each point in our pre-image as it is in our image. So looking at our reflection, if we fold our paper again from A, so the first thing we did here, our first triangle, I'll go ahead and draw a new triangle here. So if I'm going to draw a new triangle and reflect it across the y-axis. And then I'm going to label my points A, and that's double prime, B, double prime, and C, double prime. Okay, and then I'm going to identify my line of reflection. Okay, so let's go ahead and transform this little triangle here. Let's take it across the y-axis. So I'm going to transform. I'm going to flip on the y-axis, and I should have an image that is the same perpendicular distance from my line of reflection. Okay, and I'm going to label this because that's what it asked me to do. So if this is A, this is my first transformation. This is my second transformation. So I'm going to go A, and I'm going to put 2 little tick marks after it, 2 prime notations. If this is B, this would be my B after my second transformation, and this is my C. Okay. So what was our line of reflection in this? Well, we reflected across the y-axis. So the y-axis is our line of reflection. So how does each image in your drawing compare with a pre-image? So if we look at our original pre-image here, triangle ABC, our first transformation is a reflection across the x-axis. And our second transformation took triangle ABC and flipped it or reflected it across the y-axis. So we could say triangle A prime, B prime, C prime is ABC, triangle ABC, flipped. Oh, I think I spelled flipped wrong. I need 2 P's. Flipped or reflected across the x-axis. And then we could also say triangle A, double prime, B, double prime, and C, double prime is triangle A, B, C, flipped or reflected across the y-axis. Okay, so that's a little introduction there of exploring reflections. Let's go ahead and take a look at Explore Activity 2 on the next page. So we are looking at properties of reflections. So what it wants you to do, again, is trace trapezoid. Onto a piece of paper and cut it out, and then you're going to flip it. Okay, so what we want to do is we are going to flip that trapezoid across the y-axis, and I already did that for you guys. So I have my original trapezoid here, and I'm just going to show you what that looks like again. So I transformed it. I'm going to flip across the y-axis. So here it is as an original. Okay, and then I'm going to flip it across the y-axis. All right, let's watch that one more time. Original, that's my pre-image. And then I flip it for my image across the y-axis. Pre-image, image. So the y-axis is my line of reflection. This is my image, this would be my pre-image. And so I need to make sure that I'm now labeling my new vertexes. So this would be, if this is R, this would be R prime. If this is T, this would be T prime. A prime, and P prime. Make sure you're using that correct notation there. So we're going to use a ruler to measure the sides of each trapezoid in centimeters. Now, if you don't have a ruler, you just got to follow along with me, and this does take a little bit of time because we're measuring everything. So I'll try and be efficient about it. So let's take a look at our original. We're going to look at TR, and we're going to measure that in centimeters. And so if this is 1 centimeter here, it's 10 millimeters, so 1 centimeter. I'm looking at about 9, so I'm looking at 0.9 cm. Okay, I'm going to measure side RA, so I'm going to move this over to point R. I'm going to rotate it again, and I'm looking at about 8, just a little bit less, so 0.8 centimeters. I'm going to drop this down. Measure side AP, do a little rotation here, and I think I'm looking at about 1.1, 1.2, looks like about 1.2, okay, so I'm going to do 1.2 centimeters, and then I'm going to measure side TP, so I'm going to take this, move this up, make sure it's lined up here. And then I'm going to measure that side. And it looks like it's right about 2 centimeters. 2.1? 2.1 centimeters, just slightly over. So this is 2.1 centimeters. Okay, so just like we did with our translations, now we're going to compare this to our pre-image to our image. So we're going to measure the same sides here. We're going to measure side T prime, R prime. And it looks like, again, we're looking at about 0.9 centimeters, 9/10 centimeters. I'm going to measure side RA. I'm going to spin this around here. And we're looking at about 8 centimeters again, 0.8 centimeters, 0.8 or 8/10 centimeter. Then we're looking at side AP. I'm going to drop this down and rotate my ruler here. And let's move that up just a little bit so it's aligned. We're looking at slightly more than 1. We're looking at, again, about 1.2, 1.1, right? And then we're going to look at side TP, which is our long one. I'm going to slide this up, rotate it around, and we are looking at, oops. Whoa, making a mess here. About 2.1 centimeters again, so slightly more. So we're looking at the same measurements, the same length, same side length from our pre-image to our image, which means our side lengths are congruent. They are the same size, same shape, which is what it's asking us to notice about in these ones. So what do you notice about the lengths of the corresponding sides? We can say they are the same. Let's do the lengths of the pre-image and image are the same. Okay, so side lengths are the same, side lengths corresponding, side lengths are congruent. So I'm just going to put that over here as a little tangent. And remember that congruent means same size, same shape. Okay, so now we got to measure angles. So we got to measure the angles of our pre-image of our trapezoid TRAP. It wants us to measure angle T first, so I got to line up my center here. And I want to spin that around. Line up that side, and it looks like I might be looking at right about 63 degrees. I'm going to go ahead and just measuring with accuracy here. Slightly less than 65. So anywhere from 63 to 65 is a good measurement for this. So 65 degrees is the one I'm going to go ahead and put. I think it is a little bit less, but then I'm going to measure angle R. So I'm going to slide over here to angle R. Need to spin my protractor around. And we are looking at a obtuse angle that is greater than 90, and it looks like we are looking at about 120, yeah? 90, 100, 110, 120, yep, that's what we're looking at. 120 degrees, so use your degree symbol. Slide down here to angle A, line up my vertex, spin my protractor, and looks like, if I'm lining up correctly, we are looking at about 135, so we're right in the middle of 130, 140, right? 180, 170, 160, 150, 140, yep. About 135. And then angle P. So we're going to go ahead and slide down here, spin my protractor. Oh, it's definitely not lined up right now, is it? And we're looking at what? So we've got 10, 20, 30, 40, 50, about 50 degrees. Looks pretty good. Let's see if I can line that up. Yeah, it's a little better. So between 45 and 50 degrees, let's go ahead and put 50 degrees. But anywhere between 45 and 50 degrees is probably going to be, it's definitely not 50. Okay, let's go ahead and put 45. Let's try and be as accurate as we can here. So 45 degrees. All right, so now we need to measure the angles of our image. So corresponding angles, I'm going to take a look at angle T. And I know this is kind of time consuming, guys, but it is important because it's showing us how angle measurements of our image and pre-image compare. So we're looking at here, we're looking at about 65 again, right? And 20, 30, 40, 50, 60, right in between. We're looking at 65 degrees for angle T prime. Slide down or slide over here to R. I have to spin my protractor around and line it up. And looks like, let's see, line this up here. We're looking at about 120, 90, 100, 110, 120. Yep, so we're looking at about 120 again. 120 degrees for the measure of angle R prime. Slide over here to angle A prime. Line up my protractor. Looks like we're looking at about 135 again, right here in between 130 and 140. So we've got measure of angle A prime, 135 degrees. And then angle P. Let's go ahead, whoops, spin this around. And we are looking at, right there in the middle again, we're looking at about 45 degrees. So what do we notice about the measurements of the corresponding angles of the two figures? Well, just like the lengths, they are the same. So measure, the measure of corresponding angles are the same. Could we say the angles are congruent? Are they the same size, same shape? Yep, we could also say that these are congruent. Okay, so what sides of trapezoid TRAP are parallel? Let's go ahead and move this guy out of here. So that means that they are two lines that have the same slope that will never touch. So two sides that will never touch, if we look at this, is going to be side TP and side RA. These two lines will continue and they will never touch each other. So we could say side, make sure you're using your correct symbols here, side TP and side RA. Okay, so I'm a little off there. And then we can go ahead and take a look at the next question, which is which sides of trapezoid T prime, R prime, A prime, P prime are parallel? Well, what do we notice? We have the same corresponding sides that are parallel, which makes sense because we have the same angles between our image and our pre-image. So we will say side T prime, R prime, and I'm sorry, I'm not on the lines here, guys, side R prime, A prime. My pen is a little bit off here. Okay, so what do you notice? What do you notice about kind of reflection and parallel images, right? We notice that the sides that are parallel in the pre-image remain parallel in the image. So sides that are parallel in the image, let's say in the pre-image, because that's our first one, our original, are also parallel in our image. So what does all this tell us about the properties of reflections? You guys had a quiz today about translations and asked you about the properties of translations. So now we're looking at the properties of reflections. And I believe that our next question here is asking us to reflect on that. We're going to make a conjecture. So go ahead and turn the page. So we are going to reflect. Make a conjecture. Use your results from E, H, and I to make a conjecture about reflections. So what can you say, kind of think about reflections and congruence? Remember, we're looking at size, shape, orientation, location. These are the things that we're looking at, right? So reflections preserve size and shape, right? We know that the side lengths and the angles don't change, so size and shape are our side lengths and our angles. Reflections preserve or do not change. Let's see here. Size, we know that because our side lengths remain the same, and shape. And shape. From the image to pre-image. But orientation does change, right? And it changes in the fact that it is a mirror image of the original. Orientation changes to be a mirror image. Right? Because we flip it across a line of reflection. And the lines of reflection we used in these examples was the X and Y axis, but again, it's not always going to be that X and Y axis, okay? So the orientation changes. Reflection preserves size and shape. Size and shape do not change, but orientation changes and the location changes, right? So we can say that the shape is congruent, or let's say image, how can we say this? Let's say figures of pre-image and image are congruent. Are congruent. Because that is just size and shape, that is not orientation. So, size and shape the same, congruent. Orientation is a mirror image, it is flipped. So how do you graph reflections? Well, we use little kind of, pieces of paper. I use little shapes here. But you would graph a reflection by finding the original points. You're going to count those points from that point's distance from the line of reflection. So here in example 1, we are going to we're going to reflect a figure across the x-axis. So it says, figure is shown, triangle XYZ, graph the image of that triangle after a reflection across the y-axis. So that's our line of reflection. So if we've got point X, it is 1, 2, 3 units from the line of reflection. So point X prime would be 1, 2, 3 units across that line of reflection. So that would be X prime. Same thing with Y. Y is 1 unit from our line of reflection, right? Remember, our x-axis is our line of reflection here. So Y prime would be 1 unit in the opposite direction across the line of reflection. Same thing with Z. It is 1, 2, 3, 4, 5 units, and it tells you right there, across that line of reflection. So Z prime is going to be 1, 2, 3, 4, 5 units in the opposite direction across that line of reflection. So once you do that, then you're going to connect your points, X, Y, Z prime. So remember that, make sure that you're using that prime notation. And that and double check and make sure that each vertex is the same distance from pre-image to image across that line of reflection. So what I want you to do, last thing you've got here, is do this your turn on your own. We are going to do this in class together. We'll check it in class together. I want to say tomorrow, but tomorrow is the weekend, so we'll check it in class together next time we meet. You are going to do a reflection on your own. And then we'll go through this guided practice together also in class. You don't need to do that. All right, guys. So that is properties of reflections. Again, it did take a little bit long time because we spent a lot of time measuring, but that's, again, to remind you that what the properties are when we're looking at transformations. Okay? So again, if you have any questions, write them down, bring them to class, and we can go over them. Do this your turn on your own. We'll check it in class next time we meet, and then we'll do guided practice together in class as well. All right, guys, I will see you on the flip side.